Hi, welcome to NPA teaching. Today we are going to discuss the higher order derivatives. Whatever we discussed up to this level is the first order derivatives. The process of differentiation can be applied several times in succession. So any derivatives beyond the first derivative can be referred to as a higher order derivatives. For example, the second derivative or second order derivative is the derivative of the derivative of a function. The derivative of the function f of x may be denoted by f prime of x and its double or second derivative is denoted by f double prime of x, or we can also say that the second derivative of the f of x. Because the derivative of a function f is defined as the function representing the slope of the function f, the double derivative is the function representing the slope of the first derivative of a function. Furthermore, the third derivative is the derivative of the derivative of the derivative of a function, which can be represented by f triple prime of x, or the third derivative of the f of x. This can continue as long as the resulting derivative is itself differentiable with the fourth derivative, fifth derivative, and so on. Let f of x be a function in terms of x. Then the following are the notations for the higher order derivative. For example, in the case of a simple derivative, that is first derivative, the first derivative can be represented as f prime of x or dy dx, or we can also say that it is d dx of f of x. Similarly, if you go for the higher order derivatives, for example, the second order derivative or second derivative, then we can say that it is f double prime of x d square y by dx square, or we can also say that d square dx square f of x. Similarly, if we consider the third order derivative, then f triple prime of x or third order or third derivative of f of x, or d cube y by dx cube, or we can also say that it is d cube dx cube f of x. This can be continue as long as the resulting derivative is itself is differentiable function. If it is up to nth derivative, for example, then the derivative notation is f n prime of x, then d raised to the power ny dx raised to the power n, or we can also say that it is dn dx raised to the power n f of x. These are the various notations which are generally used for the higher order derivatives if the function is f of x. Thus, the higher order derivatives are found by successively applying the rules of differentiation to the derivative of the previous order. For example, if a function f of x is equal to 5x raised to the power 4 minus 3x cube plus 7x square minus 9x plus 2, then how to find the first order, second order, third order, and so on derivatives if the function is differentiable? First, we are going to consider the first order derivative, or we can say that f prime of x. Then the derivative of 5x raised to the power 4, which is equal to 20x cube, minus the derivative of 3x cube, which will become 9x square, plus the derivative of 7x square, which is equal to 14x, minus the derivative of 9x, which is equal to 9, and plus the derivative of 2, which is equal to 0. So the f prime of x is equal to 20x cube minus 9x square plus 14x minus 9. Similarly, if we go for considering the higher order derivative, for example, the second derivative of a first order derivative, then it is the f double prime of x, which is equal to the derivative of the 20x cube, which is equal to 60x square, minus the derivative of 9x square, which is equal to 18x, plus the derivative of 14x, which is equal to 14, and minus the derivative of 9, which is equal to 0. So the second derivative of f double prime of x is equal to 60x square minus 18x plus 14. In the same way, if we consider the third order derivative of f triple prime of x, which is equal to the derivative of 60x square, which is equal to 120x minus the derivative of 18x which is equal to 18 plus the derivative of 14 which is constant, so it will become 0. So the third derivative or third order derivative which is equal to 120x minus 18. Similarly, you can also go for the higher order derivative, for example fourth derivative of f of x, then it will become 120. Consider another example, that is y is equal to 2x plus 3 into 8x square minus 6. So here we have a two function and we want to multiply it. So here the product rule of differentiation will be applicable. So the first derivative of a function dy dx is equal to the first term, that is 2x plus 3 into the derivative of the second term with respect to x, which is equal to 8x square minus 6, the derivative of 8x square minus 6 which is equal to 16x, plus the second term, that is 8x square minus 6 into the derivative of the first term, that is 2x plus 3 with respect to x which is equal to 2. So if you solve this, then 2x plus 3 into 16x, it will become 32x square plus 48x plus 8x square minus 6 into 2 which will become 16x square minus 12. Then if you remove the brackets, then it will become 32x square plus 48x plus 16x square minus 12. Here we have 2x square terms, that is 32x square plus 60x square which will become 48x square plus 48x minus 12. This is the first derivative of a given function. Then if you want to find the higher order derivative of this given function, then how we will do it? The second derivative of a given function, that is d square y dx square, which is equal to the derivative of 48x square which will become 98x plus the derivative of 48x which is equal to 48 minus the derivative of 12, and 12 is the constant, so here it will become 0. So the second derivative of a given function is 96x plus 48. Similarly, we can again go for the higher order derivative because the second order derivative is again itself is a differentiable function. So for example, the third order derivative which is d cube y dx cube which is equal to the derivative of 96x which is the 96 plus the derivative of 48 which is equal to 0. Let us consider another numerical example, that is the function y is equal to 5x divided by 1 minus 3x. This is in the form of a quotient rule. So here we can apply the quotient rule of differentiation. How to find the first order derivative, that is dy dx is equal to the denominator into, that is 1 minus 3x into the derivative of a numerator, that is 5, minus the numerator 5x into the derivative of a denominator, that is minus 3, whole divided by the denominator squared, that is 1 minus 3x squared. So if you multiply 1 minus 3x into 5, then it will become 5 minus 15x plus 5x into minus 3 which will become plus 15x divided by denominator squared, which is equal to 15 minus 15x plus 15x will be cancelled. So it will be 5 divided by 1 minus 3x squared. Now we are going to find the second order derivative of a given function. So it will become d square y dx square which is equal to the derivative of a first order derivative, that is dy dx, which is equal to the denominator 1 minus 3x square into the derivative of a numerator, that is 5 which is equal to 0, minus the numerator 5 into the derivative of a denominator, that is 1 minus 3x square. In order to find the derivative of 1 minus 3x square, we can apply the generalized power function rule of differentiation. So as per this rule, the derivative of a given function will become the exponent 2 into the given function f of x which is equal to 1 minus 3x raised to the n minus 1 which is equal to 2 minus 1 into the derivative of the function, that is 1 minus 3x, the derivative of 1 minus 3x which is equal to minus 3, whole divided by the denominator squared, that is 1 minus 3x square whole square. If you solve this, then it will become 1 minus 3x square into 0 which will become 0 minus 5 into 2 into 1 minus 3x, which will become 2 minus 6x raised to the power 2 minus 1. So it will power will become 1 into minus 3 whole divided by 1 minus 3x square whole square. Then it will become minus 5 into minus 3, which will become minus 15 into 2 minus 6x divided by 1 minus 3x raised to the power 4. So which is equal to 15 into 2, which is minus 30. Then minus 15 into minus 6x, which will become plus 90x divided by 1 minus 3x raised to the power 4. So this is the second order derivative of a given function. I hope you are clear about the how to find the higher order derivatives of a given function. Practice some more examples in order to familiarize the concept of higher order derivatives. Have a nice day and see you in the next video. Thank you.